Yes, multiplying powers with the same base. Okay, we just learned how to deal with exponents. Okay, zero exponents, negative exponents. Now we're going to learn how to deal with multiplying powers of the same base. So let's do a little example here to get things going for ourselves. Let's say if I do 3 to the 4th, and I want to multiply that with 3 squared. Okay, what's the answer? 3 to the 6th. Okay, everyone knows that that's the answer. Why is that the answer? Yes, you add the powers, but why do you add the powers? Because that's what my teacher told me to do last year. Yeah. Yes, they do have the same base, but why do you add the powers? How come it's not 3 to the 8th? We're multiplying the bases. Why don't we multiply the exponents? I don't get it. I love the discussion you guys are having right now.
It's because the coefficients are the what's it called? No. I think she called the exponents like outlaws.
Outlaws. Now we're just making things up.
Oh, no.
Okay. All right. Let's just break it down to in terms of what it means. Okay. You guys are like almost on the right track, but I mean you have a good understanding. You know the answer is 3 to the 6th. Okay, but now is the time where we understand why it's not 3 to the 8th. Okay, let's just go back and let's build. Remember, math is all about building upon what we already know. What does 3 to the 4th represent? What does it mean? It means this, okay? It means 3 times a 3 times a 3 times a 3. There are 4 of them. That's what it means. What does 3 squared represent? 9. No, it really represents 3 times 3. Okay, good. Now, notice, this is why they have to be the same base. If they were not the same base, then I would have digits here that don't line up and don't match. They have to be the same base. Okay, now, this is where the 6 comes from. This is why. How many do I have here? How many 3's do I have? How many do I have here? 2. I have a grand total of 6. So this is nothing more than 3 to the 6th. That's why you add the powers, not multiply the powers, all right? That's the big idea. That's the main idea behind this. So, in general, here, I'll put a nice little box for you. If we have a to the m, and we are multiplying that with the same base. So the base has to be what, you guys? A, good, to a different exponent. What do we do to the exponents? We add them. We add them up because it represents, that's an n. M plus n, because it represents the sum total number of bases that we have collectively. Okay? That's what it means. I can see the argument for many Algebra 1 students go, well, if I'm multiplying 3 and 2, why don't I just multiply 4 and 2, right? I get that logic, but that's a misconception of what it means to be an exponent. All right, we all on board with this so far? Okay? You feel a little bit better about why this is what it is, Will? Yeah, all right. Whew. Okay, let's try this without a calculator, see if we can do it. What is the written in terms of the base only once? Okay, so what is the base in each of this, in this problem? Yeah, notice that the base in all of these is the number 9. The base is the number on the bottom, right? We're taking the number 9, raising it to a power of -3, 2, and 6, respectively. So, I have one exponent that is negative. I'm going to identify that. That's this one here. My other exponents are positive. So I'm going to make the move. This is going to go down on my fraction. So I have this. I have 9 squared times 9 to the 6th, all divided by 9 cubed. So far, so good? Okay, good. Now, what is 9 squared times 9 to the 6th? That's 9 to the 6 plus 2 is 8. Very good. Divided by, now I have 9 to the 3rd. Now, what do we do in this case? We subtract the powers. Why do we subtract the powers? If you write it out, it works. What do you mean by that? Let's go ahead and do that. This means 9 how many times? So 1, 2, 3, 4, 5, 6, 7, 8. On the bottom, how many do I have? 1, 2, 3. I'm multiplying everywhere, right? This right here is a big fancy number 1, right? 9 times 9 times 9 divided by 9 times 9 times is the number 1. So I'm only left with how much? I'm only left with this much, which is written as 9 to the 5th. And noticing it's the same thing as 8 minus 3. So the answer is 9 to the 5th written in exponent form. All right, let's work together and try and simplify this thing right here. Ugh. Can we even simplify that thing right there?
Yes.
Yeah, we can do something, right? Okay. Let's identify any negative exponents. Do you see any negative exponents?
Yeah, C to the -2.
Only this part, c to the -2. So that's definitely going to come downstairs. Okay? Okay, so far so good? All right. Could I approach this a different way?
Yes.
Could I approach this a different way without doing this? Do you guys see a different way here? Daniel, what do you see, buddy?
You can subtract the c to the third to the c minus -2.
Well, I don't actually have to move it anywhere because I am multiplying together, right? Okay. So let's do this. Let's take a different approach to this problem, all right? Let's multiply all my coefficients together, okay? All those numbers in blue. How much is -4 times 7? How much is -28 times 2?
-56.
-56. So how about, what if I rewrote this like this? -56 c to the third d squared c to the -2. Now we're taking a different approach to this, right? Which two bases have this, or have the same, which exponents have the same base? That's a better way of asking that question. C to the third, c to the -2. What do you do when you multiply those together? What do you do to the exponents? We add them, right? So we can visualize now. 3 plus -2 is -56 d squared. 3 plus the -2 is just 3 minus 2. That's just c. So there's our answer. So would I have gotten the same thing if I had done the original idea of moving the exponent to the bottom?
Yes.
Yeah, because I would have had 3 c's in the numerator and 2 c's in the denominator. When I divide them out, I would only have 1 c in the numerator, and that's exactly what it says right there. Okay, challenge problem. See if you guys come up with the right answer for this one. Now, we haven't actually said, what works for integers works for fractions. A little bit of magical hand waving here, but it does work, okay? The same rules apply for fractions as they do apply for integers here. So I'm letting you know ahead of time that we can use a little bit of magic and hand waving and say, yeah, well, if it works for integers, it should work for fractions too. So try this one with a partner next to you. Okay, Brandon, what'd you do? What do we do?
So I found that I multiplied 2g by 2g 56 by 2g.
Okay, so you kind of group them together. So you have 2g to the 5/6, and you're going to multiply that with, what? 2g to the 3/2, right? Is that what you did?
Yeah.
You group them together, and then you're going to group the d's, right? So you have 7d to the 3/2 times another 7d to the 5/6. Okay.
And then I got 4g
This is 4g to the
to the 7/3.
7/3. Very good. Okay.
And then 49d to 7/3.
49d to the 7/3 as well. All we have to do is multiply the 4 and the 49, and what do you get?
196d to 7/3 and g to 7/3.
There you go, 7/3 d 7/3, and that is the right